Hello, Tom Cosm here. Welcome to part one of a massive series of free videos I'm putting out there on sound design with Ableton Live with a bit of a twist. We're going to be talking about different ways to design sounds, not just synthesis, kind of utilities. We're going to be using Max for Live, weird routing, all the crazy shit that I can think of. And we're going to build these sounds based off all these cryptocurrencies here. So these are all cryptocurrencies which people trade on the markets. And the reason I'm using cryptocurrencies as the inspiration for the sound design is because I'm making a machine that gets live market prices of all of these and then plays, or it needs to play a sound depending on whether the price is changing, going up, going down, example. And I thought, what a good way to do a whole new series, because each one of these needs a sound. So while I'm going through these videos and making these tutorials, I want to invite you guys to think about what the next sound could be. So I'm going to be doing Bitcoin today, but think about what Litecoin could be. I mean, it could be a light switch turning off and on, it could be a light fluffy pad, and I really want you guys to comment and let me know what you think is a good idea for the next one, because I don't think I can be terribly creative, because there's 64 of these, which means 64 videos, so let's see how we go. So we're doing Bitcoin today. Now, Bitcoin, there's a very standard kind of 8-bit coin sound in video games, and I love 8-bit sounds and chip sounds, and a lot of you are probably familiar with it already, but we're not going to duplicate that, we're not going to completely copy it, we're going to do something similar though, and for that we're going to be using today an analog. So an analog is one of Ableton Live's native synthesizers. It's a very simple subtractive synthesizer, but it's got some grunt and it's got some parameters in it that we need to use if we really want to kind of emulate that old kind of 8-bit. I'm going for the NES kind of sound chip sound. And so I've just simply got an analog here. I'm just going to throw in a note. Let's just make it a C, like so, and we'll just play it here. Now the first thing you'll notice that will happen is it starts loud and then goes quiet very quickly, even though I've got the note completely dragged out across the entire MIDI editor. So let's just hit play again. That is because if we go into the analog and we go into our amp or the amplitude, which controls the volume of the note, you'll notice that the sustain time is at 0 and the decay time is at 6 to 6 milliseconds. So that means at the attack it's going to start loud, it's going to take 6 to 6 milliseconds to get to the sustain point, which is 0. Now if we want that note to play completely, or play as long as we actually put it into the MIDI editor, we just bring the sustain up to 1. So now if we go back here and play it, excellent. Now I'm going to go back to the analog. At the moment our wave shape is a saw wave. I'm just going to add an oscilloscope in here just so we can, sorry, spell it right, just so we can actually see that. Where did I put it? There it is. Just so we can see that wave shape. So at the moment we're playing a saw wave. Let's just bring this on, and you can see the wave shape here. So this is what is happening hundreds of times, thousands of times per second. It's pushing the speaker and pulling it out, and it's doing it in this particular shape. And that particular shape gives us that characteristic sound of a saw wave. But we can change this to a square wave, which is a lot more fun if you're going for the 8-bit video game sound. So let's have a look. So you can see now we've got a kind of a very square looking shape here. What we can do here though is we can play with the pulse width. Now the pulse width is in a percentage, and it determines kind of how much of the uppers and how much of the downers, if you want. It kind of gives us an ability to make fine tuning to how that square shape is. So if I just play this and drag the width down for you, kind of get that cool phasing effect, and you'll see now that it's only up for a very short amount of time. And if we bring it down, excellent. Now, with the old NES chips, what they did with their square waves or pulse waves, if you're going to use the pulse width parameter, what they did is they gave people, I believe it was 4 different settings. So you could have it at 0%, you could have it at 25%, you could have it at 50%, and you can have it at 75%. Of course, 100% being the exact same as what it is when it's 0. So that's all good. But you couldn't morph between those two values. You could only have those exact values. And if you played them really fast with that pulse width kind of almost like arpeggiating, if you like, it creates a really unique tone, which is very, very characteristic of chip sound music, especially with the NES. So what we're going to do here is we want to modulate this width somehow. So one thing we could do is we could go into our Max for Live folder in the device browser over here, we could go down and we could pick the LFO, which is right past it. We put the LFO here. So the LFO Mix for Live plugin, it gives us this wobbly line, it's moving up and down and up and down. We can map that to anything that we like, so we could map it to, say, the volume, and the volume starts going nuts. We don't want the volume, we want the... Go back over here, whoops, go back to the pulse width. So now the pulse width is going nuts. But again, because it's a sine wave in the LFO, it's moving nice and smoothly. You'll notice it's not giving us exact values. We want exact values. Well, one thing we could do is we could change the waveform to a rectangle. So that now that's going from 0 to 100. Let's just play that note. We're getting nothing. Oh, it's because I turned the volume down, excuse me. Hit delete to reset that back to default. And you can see this width is now moving up and down. But the problem we run into here is I want to have more than just up and down. I want to have a bunch of these. I want to have 0, 25, 50, 75, and I'm going to go for 100% as well, because 100% actually sounds different to 0. It doesn't seem like it goes full circle when it goes back to 100. I'll look into that further afterwards, but for now we can just roll with the fact that it sounds cool. So I'm going to get rid of the LFO here. Now I'm going to get into a little bit of Max for Live here. So throughout these videos I'm going to start kind of introducing ideas of Max for Live, how it works. It's not going to be a full beginner tutorial, you probably need to know a little bit about it, but I'll just talk as I go along. So I'm going to create a new Max audio effect here. Now Max for Live of course lets you build your own stuff, your own Ableton stuff. It means I can make utilities. I could create an LFO that has different points here, or something that resembles an LFO, and that's exactly what I'm going to do right now and show you. So once I've loaded in a blank Max for Live audio effect, I'm using an audio effect because that means that audio will pass straight through it. You'll see we've got very basic 2 objects here. These things are called objects, and objects have a particular purpose, and there's heaps of objects you can use, and you can link them all up. But we've got 2 here. It says plug in and plug out, and you'll notice plug in has a left and a right, plug out has a left and a right. So that means audio that comes into this unit gets fed out of plug in, and then when it feeds into plug out, it comes out of the unit. And you could put a whole bunch of things in between these 2 points here on the left and right channels. You could put delays, you could put reverbs, you could put all kinds of things, and then that would affect the audio and then spit it out as a different sound. But just for now, we want the audio to go straight through here because we're going to be using this as a utility. So I'm going to click on this button here, which opens up the environment of which we can actually work with the Max for Live device that we've created here. And you'll notice we've got a big kind of workspace area. This is where our stuff was before, so this is the representation of this. I'm just going to leave that as it is, because that lets us keep the audio flowing through. What I want to do is I want to create a 4, maybe 5 step kind of arpeggiator or an LFO that has 5 separate steps, so we can get this width going from 0 to 25 to 50 to 75 to 100 and repeat that over and over and over. Now, one of the easiest ways to do this, or to actually make sure that this particular Max for Live patch that we're working with affects the thing that we want, which is the width, is we can right click anywhere in our workspace, we can go paste from, we can go live API chooses, and we've got a whole bunch of kind of really handy preset bunches of objects here that let us do things with Ableton Live. Now these choosers let us choose something in Ableton Live. So what I want is I want device parameters. So I could just pick devices, which would just let me pick a whole device, say the analog as a whole, but I want the device parameters because I want a parameter within a device, and of course the device being the analog. So let's click on that, and it gives us this selection of things here. And what this does is it lets us very easily select a parameter from anything within Ableton Live. So what I do is I'm just going into the kind of, I forget what the mode's called here. Well, we'll lock it, and that means I can actually start clicking on things. So this one you can kind of edit and create and drag and drop and link things up. This one means you can actually try and operate it and see how it goes. So I'm going to go list track. So it lists all the tracks that I have in my project. So we've got 1 analog, 2 MIDI, 3 audio, 4 audio, which is the default. 1 analog is the track we want because that's where I put the analog. It's named it for us, which is nice. And then it goes, okay, well on the track 1 analog we have a bunch of devices. So I'm going to go, okay, well I want the analog device. and it takes a second. It's grabbing the analog device, it's analyzing the analog, it's finding all the parameters, and it goes, okay, well these are all the parameters of analog, which one do you want to affect? So I'm going to open it up, and we see we've got all the parameters here. We've got everything from volumes to pitch to pan to everything. I want the oscillator 1 PW, which stands for pulse width, which if you remember is this guy here. So the oscillator 1 PW, I select that, and what it does is it spits out an ID at me. So it says, okay, the ID of this pulse width, which is here, is number 5. Now everything within Ableton Live pretty much has an ID. It doesn't matter if it's a track, a clip slot, a mute button, a power button, a parameter, you name it, it will have its own unique ID. And that's the way you can use Max for Live and tell it what you want to change or what you want to watch or where you want to get information from. You need an ID of something. So now I have this ID 5. This is great. That ID 5 is specific to this width of the pulse width on this particular analog, not any other analogs, just this one. So that's great. So now what we need to do is I'm going to add a new object here. You can do this by pushing N, and then you just start typing, and then and once you've typed what object you want, you push return. I'm using an object called a live.object, and once I've hit return, it gives me this thing here. You'll notice it's got two little things at the top. These are your inlets, so this is where you feed information into it, and then at the bottom we've got an outlet, which is where stuff comes out of it. So a live object is an object that takes an ID from something. So this is where you found your ID, this lot here. I've got my ID, so I can feed my ID into the right inlet here. So that's saying, right, this live object is now specifically catered towards the pulse width of the analog. So what I can do here is I can click on the ID 5 just to send it to this live object. So click it, boom. Now you can't really see any results, but now this live object is locked on to the pulse width. Now I can do various things into this left outlet here. I can do things here. If we hover over, we can get information about it. We can set various things on it. We can do various things like that. So I want to get something for the start right now. I'm going to create a new thing called a message box. So a message box is M. This is where you can type in texts or strings or messages and send them to various objects within Max for Live. And I'm going to go get min. So get min, if I link that up to the left inlet of this live object, when I click on get min, it's going to go, hey live object, I want you to get the minimum possible value of whatever this ID is. And of course the ID is the pulse width of the analog. So that's all good, but I need to also have something for live object to send that information to. So I'm going to create another message box here, and we'll just drag it nice and neatly there, and we'll drag it to the right inlet. Now if a message box, if something is dragged to the right inlet, when it receives information, it's simply going to update on the inside of the box with that information that it's received. If you send something to the left inlet, you'll send that information out the bottom left inlet, but if you just feed something into the right upper inlet, it will just update it for you. So that's good. So let's have a look here. I'm going to click on get min. Great, and it's gone, right, the minimum is 0.1. Now you might be going, no, why is that? Because this is in a percentage and this is not in a percentage. Well, I'll show you in a minute. So that's all good. What we can do now is we can go, okay, well, let's find out what the max is, which of course is what the maximum that is. So I click on that and it tells me max equals 1. So even though this width visually goes from 0% up to 100% within the actual analog, we actually need to send it information if we want to change it from within this Max for Live patch of 0 point to 1 point. So anything, so we could have 0.5, we could have 0.25, we could have 0.33333. That's the kind of information we need to send to this. We can't go over 1 and we can't go below 0. So that's all good. So now I know what the minimum and maximum is. I can actually get rid of these. So I can get rid of that 1, 2, and I'm going to create a message box, and I'm going to call it 0, and I'm going to call it 0 point. So there's two types of numbers. There's floating point numbers which have a point and decimal place, and there's numbers which don't have a decimal place, which are called integers like that. So what we want to be working with is we want to be working with these floats here. So I have a 0 point. I'm going to hold down the Option key and copy this across, and we're going to call this 0.25. Great. And I'm going to drag this across again, and we'll call this 0.50. Or 0.5, excuse me, excuse my bad maths, and then we want 0.75, and finally we'll go, oops, click, 1 point. So now, if we send this, if this got converted into a percentage, we'd have 0%, 25%, 50%, 75%, and 100%. Now that's awesome. So now, what would be cool is if we could link this directly into the live object, click on a thing, and it would change the pulse width for it. But we do need to add one more thing. When you want to set a value, you'll notice when we hover over, it says set. So we need to actually put set before the number to actually set that value. So just as an example, if I go set 0.5 like that, and I drag that into, excuse me, it needs to be set value. Set value 0.5. Now if I click on this, watch what happens down here in the pulse width. Boom, the pulse width changes for us to 0.5. So that's good. So now I need to convert all these into the set value thing. So, but instead of actually typing set value before each of these float numbers here, what I'm going to do is I'm going to create another new object, and this one is called prepend. And what prepend does is it jumps in between kind of chords that you patch things together, and it adds something to the start of a message. So if I go prepend set value like so, and let's just say I have a message box here going hello, and I have another message box here. If I connect hello to the inlet of prepend set value, and I attach the output again into the upper right inlet of the message box. Now if I click hello, it says set value hello. Let me just drag this out to make it bigger. So you'll see prepend adds whatever you put after the prepend before the message gets sent. So what we can do here is we can now connect this 0, this 0.25, this 0.5, this 0.75, and this 1 to this prepend set value, and we can take this chord and feed it to the inlet here. So now each time that I click on one of these, it's going to add set value before it, and it's going to change the live, it's going to send it to the live object, which again is attached to that pulse width. So let's have a look. Let's click on 0. Watch down here. Click on 0, 25, 5, 0.75, and 100%. Cool. So now, let me just make this a bit smaller. Scroll down. Let's play this analog clip again. And let's click on these. Awesome, that's kind of getting where we want. Now, I was just clicking those. What we need to do now is we need to make these play in succession. Okay, so we need something to automatically play these 5 or trigger these 5 messages, or the correct terminology is bang. So a bang is something that sends a bang message. It says trigger, do something, go. So a bang, if I push B on my computer keyboard, this is what a bang button looks like. And I can hook a bang up to anything. So if I click on this bang, it's going to bang that 0. If I hook it up to the 2, it's going to bang the 2.5. So that's what we want. I'm going to have, let's just make 5 of these bangs for each 5 of these values. Just holding down the Option key to copy these across. And we'll just connect them all to those message boxes. Excellent. So I want it to go bang, 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 and then go back and bang, 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 repeat over and over and over. Now there's a few ways you can actually do this in Max for Live. It's such a versatile programming environment that there's all kinds of ways. But the way that I personally approach this is I use something, or an object. Remember, pushing N to create a new object. I'm using something called a metro. Now a metro will continuously send out a bang message out of its bottom outlet. It will continuously bang over a period of time that you specify in milliseconds. So I'm going to say bang metro 500. What that does is it will continuously output bangs out of this bottom left inlet at every 0.5 seconds, every half a second. So if I add another bang here, send the metro into the inlet of this bang, I'm going to add a new thing here called a toggle. So that was T. So this is a checkbox, and I'm going to add the checkbox to the inlet of the metro. That means I can turn the metro on and off by ticking this box. So let's have a look. And you can see this metro, every half a second, it's now banging for us. Excellent. But the problem is here, we can't just connect the Metro to all 5 of these because it's just going to bang them all at once, all 5 of them at the same time. We don't want that. We want it to cycle through 5 separate bangs. So we create a new object, funnily enough, called cycle. Now cycle needs a number as well. It says how many different cycles are we going to use. You'll see the description here says round robin messages to other outlets. I want 5 because there's 5 separate bangs and 5 separate parameters here, so we go cycle 5. Great, so now what I can do is I can connect output 1 to the first bang, output 2 to the second bang, output 3, third, 4 to 4, 5 to 5. And now what we can do is, I'll turn the Metro off for now, we can drag the output of the Metro, so this is going to bang, 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 into the cycle 5. So each time the Metro sends a bang to the cycle 5, it's going to move to the next outlet and bang the next parameter. So let's turn it on and have a look. Excellent, and if you look down here at the width, the pulse width here, you'll see it's doing exactly what we want. So let's just play that note now. Now we've got it automated. Let's make the note lower. Excuse me. Okay. Now one last thing we can add to that is this Metro 500, it's at a fixed rate, so it's playing, it's only playing every half a second. What if we created a new dial here, so something that a user could actually use, a user interface object that a user could specify how quickly this kind of sequence of different pulse widths happens? Well, we can do that by going, we're creating a new object, and we're going to use one here, which is called a live dial. And you'll probably be familiar with this once I hit return. It gives us a user interface object, which is an Ableton Live dial. So by default, this dial, what we can do is we can right click and go inspector, and it's just up here in this other window. The inspector gives us all the different preferences and things that we can say about this dial. For example, if we scroll down, you can see the short name here, it says live dial. Let's call this rate, like so. And you'll notice that the dial now has rate above it. We've also got various things like, say, the range. So the range at the moment goes from 0 to 127. So if I go here and move this dial, it goes from 0 up to 127, down to 0. Well, we don't want 0 to 127 for this Metro because we're working in milliseconds. So we could probably say we want to go from maybe 50 milliseconds, which is really fast, up to, say, 1,000 milliseconds, which is every second. So we can do that. We can go here and we can go, right, I want the range to be 50 point as the minimum and then 1,000 point as the maximum. Hit return, and now you'll see this knob goes from 50 all the way to 1,000. So this upper right inlet on the Metro lets us to set the metronome time interval, and we can do that by outputting the rate of this dial directly into that inlet there, and now this rate knob will allow us to move up. Well, we can go very slowly, or we can move it down and go very fast indeed. So let's see what that sounds like. Excellent, so that is our utility pretty much done for this part of the tutorial. We're going to be doing a little bit more in a second. It's going to be a big tutorial. The last thing we need to do is we need to go into the actual patching inspector, and we can do this by right clicking anywhere and going patching inspector, and this determines the behavior of the whole patch as a whole. And what I want here is I just went to the basic options here. What we want is we want open in presentation mode. What this means is when the patch is opened within Ableton Live, we have a presentation mode displayed rather than all of this stuff here, which is the guts, which is where all the action actually happens. We actually want to be able to offer the user who is going to end up using this just the things that they need in order to change it, which of course is the rate value and the parameter value here. So I'm going to go open in presentation. We can close down the inspector now. Now you'll see I can right click on the rate and go add to presentation. A red box goes around it. That means that this particular thing will be included in the presentation, and I want to select this, this, and this, and add them to the presentation as well. So now if we go into presentation mode, which is here, you'll notice it's given us a line as to how high the actual things can be, because remember the device area in Ableton Live is relatively small height. We can drag these things now, so we can go over here, and we can bring the rate here. And let's just add one comment, which is C. This is just so you can put text in, and let's just say select pulse width. Now we can drag that up to the top, like so. Move it across. That looks good. And now that is our presentation. So we can now go and save this. Save as. We'll call it, just for now, pulse width sequencer. And we can save that. And now that is saved. So now I can go back to Ableton Live. I can go back to my analog track. I can close it down so it's no longer edit mode. And now we have our first Maxwell Live device, which is a pulse width sequencer. So again, I have to remember to list all the devices. I want the analog, I want the analog track, I want the analog device, and the parameter, I want the oscillator 1 pulse width. And now, we also need the tick box to turn it off and on. So that was my mistake there. So the tick box, let's go add to presentation. And we'll put the tick box here, put the rate here, we'll put a comment that says on. Make it all neat. Excellent. So now we can go back here, turn this off, and turn that on. Let's make sure we select the pulse width again. What's going on? This track. Turn off. Analog. Parameter. Pulse width. And it doesn't seem to be working for me right this second. So let me troubleshoot why this isn't working. So let's go back into our edit mode here. Turn it on. Okay, the reason it's not working is because I made a mistake here, and I connected the output of this message box to the live object. Now this isn't going to work because the message box isn't receiving anything in the top left inlet at any stage. So all that's going to happen when we select the pulse width of the analog is it's going to send it to the message box, but just update it. It's not going to follow through and go to the live objects. So what I can do is I can simply delete that and drag this directly down into the live object like that. So now once we pick that final parameter, it will inject the ID straight into the live object for us. So sorry about that. So let's go back here. Let's try that one more time. So list this track. We can choose this track if we like. We don't have to choose the one analog track. We want the analog, and again we want the pulse width. So now when we turn that on, there we go. We've got the sequencer happening now, and we can change the rate however we like. And just for fun, let's add that oscilloscope in again and see how it looks. Great, so that's a good start. Now what I want to do is I want to find a cool little sequence for this Bitcoin sound. So something that sounds like a coin, something kind of fluffy and light. Now one thing I didn't mention at the start of the video here is I need this sound to be not pitchable. So it needs any note that plays, it has to play the same sound. However, the velocity of the note, which of course is the bar that you've got down here, the velocity will determine something about that sound, some characteristic. And this is because with this machine that I'm making, the ultimate big machine, is that say there's a price change in the Bitcoin market and it goes up, that's going to send a velocity value of a higher value, and that in turn, that velocity is going to tell this particular sound to do something a bit more drastic, or play something faster, or play something slower, or louder. If the price drops, the velocity is going to be down, and it's going to go down below halfway, and then we're going to have the opposite effect. It's going to play slower, it's going to play less drastic. So that's what I need to do here. So first off, I'm just going to find a cool little sequence here that'll work with our sound that we've just created, which is very simple for now. So I'm going to get rid of this. Let's put in... Let's try a major 7 chord. Major 7, and we'll put a 9 up the top. Now let's go back into our analog. I'm going to go into our amplitude here, and I'm going to give it some release time. So the release time means that the note will continue to play out and slowly die away once the note off signal has been sent, so when the note actually ends. Let's make it a second and 2 seconds. That's alright, but you'll see that each note has that release on it, and I don't want that. So I'm going to go into my kind of general area over here, and you'll notice we've got a voices parameter. A voices says how many different times can this synthesizer play at once. So at the moment it's 8. That means I could play 8 chords, and the synthesizer would play 8 chords, 8 separate notes. Sorry, not 8 chords, 8 separate notes, and it would play all 8 of them for me. So this is voices. So you can have lots of voices. They use up more CPU the more voices you do. But if you go mono, it can only play 1 at a time. So that means that each time this new note kicks in, it's going to cut short the tail of the one before it, because it's only allowed to play 1 at the same time. So let's listen to it now. Let's make them shorter. Let's make the BPM faster. That's cool. Let's make the length 2 bars long. And just for fun, I'm going to add a reverb on it, and we're going to turn it into a low cut, so that last kind of nice little note is going to go with quite a lot of decay. I think that's a really neat sound. Let's change the rate on our Max for Live patch we made. Excellent. So our next step here is I want that little sequence to not actually be played by MIDI clip. I want it to be played by another Max for Live instrument, which is a MIDI effect. So I'm going to go into my Max for Live area here. We're going to close down the audio effects, and we're going to go Max, excuse me, Max MIDI effects, and I'm going to create a new Max MIDI effect. Now, just like before, remember when we had the blank audio effect, it's given us 2 objects by default, but this time it's MIDI in and MIDI out. And because it's a MIDI effect, it goes before the device that creates sound, so in this case, a synthesizer. So the MIDI effect goes before that. So MIDI that gets sent in comes into this MIDI in, it gets sent out, and it goes directly into MIDI out, which outputs the MIDI here. So at the moment, nothing is going to change. The MIDI is just going to go straight through this device. So if we play this clip again, it goes straight through. Now I'm going to open this up here, and once again I'm going to close down the inspector. We have a workspace. Now this is a little bit different because we're going to be working with MIDI notes here instead of actually audio feeding through. Now we've got MIDI in and MIDI out, that's good. So the MIDI in that comes in here will be a bunch of information, raw MIDI information, but we don't want that because I want to get a note coming in. So I'm going to create a new object, and this is going to be called note in, and it receives MIDI note messages. So it's got 3 outputs here. We've got pitch, velocity, and MIDI channel. So I'm just interested in the velocity and the pitch for this. So I'm going to create 2 message boxes, 1 message box, hold Option, copy it across, and I'm going to feed the pitch into the upper right inlet of 1 message box and the velocity into the other message box. And that will give us an idea of what information is being sent into this Max MIDI effect when I play that audio clip. So let's play it. I'm going to have to be creative here. Bear with me. There we go. So I'm going to play this analog. Let's slow it right down so we can see. So you can see we've got this is the pitch, so the pitch will be 0 to 127 because that's how many MIDI notes there are, 0 being the lowest, 127 being the highest. and this is the velocity. So what's happening is it's sending out a pitch number, and then it's sending 100 velocity, and then it's sending 100 velocity, and then it's going back down to 0, which is basically turning the note off, and it's doing that 5 times. So you see those notes, C, E, G, what do we have, B, and we had a D for the ninth. Those are the values, those are the MIDI note values if you convert them into 0 to 127. So that's good. I'm actually going to get rid of this MIDI clip here, because I'm just going to be using my keyboard here to play the notes. So I'm going to have to make this smaller somehow. Let's go this way. Get rid of our send returns and move this over. I usually have 2 screens when I work with this, but we can make do with what we've got here. Okay, so if I go back to live here, I'm pushing C. We go an octave higher. You see it plays 60, 48, 60, and of course that means there's 12 semitones in an octave. Well, that's all good, but the thing is I'm not going to be concerned with the pitch here, because as I said, I want every single note that comes into this MIDI effect to send out the same sequence at the same pitch. So I'm going to do that by, how am I going to do this? I'm going to say, okay, first thing we're going to do is we're going to put in a keyboard for you to have a look. So I'm going to double click here because I can't remember what the actual object is called. This brings up a cool Explorer for us. I've chosen UI objects, so user interface objects. If we scroll down, we'll see something that looks like a keyboard. K-slider, that's the one. So if we open up a K-slider, I put it here, it gives us a piano, and we can click on this piano anywhere we want. It doesn't do anything by itself. Now if I go into the inspector for it, we can change how many notes there are. So I want 128 notes, because there's 128 notes, MIDI notes, and the lowest MIDI key offset, well, I want that to be 0. So that means that this is now the full range of MIDI notes that are available to us. It's quite big. I wonder if I can make it smaller. Yeah, we can make it smaller. There we go. So now if I connect a message box to the outlet of this K-slider, again going into the upper right outlet, we can now click on this and it will give us what that particular value is. So you can see we've got 0, 2, 3, 4, 5, all the way up like so. Now what I want to do is I want to capture that note sequence I played, and I want to get all of their numbers. I want C, E, G, B, and then this D up here. So let's just look at what we've got here. We've got C, so that's 60. So I'm just going to create another message box here. I'm going to say 60. I'm kind of just saving these for later. And then let's duplicate that across. Then we've got an E. So E is 64. So let's go 64. Then we've got G, which is 67. Oops, 67. We've got B, which is 71. 71. And the D up the top here is 86. Great. So now I've saved those for later. We'll just put them up here for now. What we could do is we could go, as we have a note in, we also have an object called a note out. Now this will transmit MIDI note messages. It will send whatever MIDI value I send to it, it will send it to the note out. Now there's something which helps us here, which makes it a little bit easier, because when we send a note out, we need to send a pitch and we need to send a velocity, but we need to also send a 0 once we've finished playing the note for the note to go off. And that can be kind of annoying to actually put in there, because you have to kind of create a whole new little system of making sure the note gets turned off. Otherwise you get the MIDI note on forever and it gives you all kinds of problems. So there's another handy object here which is called make note. Now a make note will make a note for a certain amount of time with a certain velocity. So I'm going to give it 60 for a velocity and 1,000 for how long the note's going to last, which is a millisecond. So now this make note, all I have to do is feed it a pitch, and it will send out the pitch to the note out, and it will send the velocity out and when the velocity is off. So it will turn the velocity on to 60 for 100 milliseconds, and then, sorry, 1,000, and then it will turn it off, so it will send a 0. And that's really handy. So now that means we can put, we can connect this K-slider to the make note out, and we can hit a note, So now that's directly feeding in Ableton Live, it's directly feeding out of this max MIDI effect to that analog for us. So we can actually play a little melody here on our K-Slider keyboard and it will make that note for us. Just if we attach a message box really quickly to the velocity here and over here to the pitch, just so you can see what it's actually doing, that make note. So see how it sends 60 and then it sends 0. And we can change the velocity here if we want. We could say, I want the velocity to be 100 instead. So now when we click a note, it'll send 100 and then note off. Excellent. If we want the notes to be shorter, we could make this 200 milliseconds. I'm going to leave it at 200 for now. So that's really handy. So now we've got that. We've got the saved numbers here of what notes we want to play. So what I could do is I can get rid of this keyboard. I can get rid of this keyboard altogether and this message box, and I can connect these to the make note. So these are the 5 notes that we want in a nice little sequence. So hopefully you can see where I'm going here. Now if I click on these, excellent, we've got ourselves a little sequence. And of course what we can do now is we can use the same kind of cycling bang method that we used before with the audio effect for that pulse width. We can use the same thing to trigger the sequence for us. So I'm going to do that right now. I'm going to create a metro, give it 200, so it's playing a note every 200 milliseconds. And I'm going to create, after the metro, we're going to create a cycle, remembering a cycle will send each one of those bangs out 5 different outlets. So the metro goes into the cycle, and the cycle will send the bangs to that note, to that note. Remember, if you connect it to the left inlet, it's going to send whatever value down the pipeline to this make note thing. So that's the upper left inlet, like so. So now that's, oops, wrong one there. So we need a toggle to turn the metro on and off. And now when we turn this on, it's going to go bang, 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 bang. Great. Now, the one thing we want though is when it hits this 86 here, I need it to stop, because the problem we're gonna face here is that the it's just going to keep looping over and over and over until we turn off that metro. So let's just tidy it up a bit here. I like to keep things neat because they can get a bit out of control sometimes. Move that over here. So what we need is when this 86 is triggered, you see it's going to send the 86 down to this make note. But what we can also do is we can have it to turn off the toggle. Now a toggle works in a very simple way. If I connect a message box to the output of the toggle, if I turn it on, you'll see it goes to 1, and when I turn it off, it goes to 0. So all the toggle is doing is it's sending 1 and it's sending 0. 1 meaning turn on, 0 meaning turn off. So we can reverse this around and go, well, actually I want to put a 0 up here, make it smaller, and I want to have a 1 as well. And if I connect the outlet of the 1 to the toggle and the outlet of the 0 to the toggle, that means we can turn the toggle off by clicking 1, and we can turn it off by hitting the 0. Now this is handy because now what we can do is we can say when this 86 plays, go back and hit that 0. So once the last note is actually played, once it's sounded, I want you to go and turn off the toggle, which is making the whole sequence loop itself. And one way we could just simply connect this to this. That's alright, that will work, but it's a pretty bad habit. A good thing to get into is using things called triggers. So if I create a new object and I call it trigger, which is just a T, because I want to split the output of this into 2 separate things. I want it to send the actual value, which is 86 over here, and I want it to send a bang up to here. So we do this by going T, bang, I. I stands for integer. So it's going to create 2 outlets for us, a bang, and it's going to create an integer. And an integer will take the input and feed it'll feed the number that it receives out this outlet over here, but this outlet will send a bang instead, and it goes from right to left in order. So you could have bang, 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 integer, integer, bang, bang, and it will always do it in the sequence from right to left. So always remember that. So I want this 86 to go out first to the note, and then I want it to bang, and I want that bang to come up, loop around, and turn everything off. So once I turn this on, it'll go bang, 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 send the final note, and then turn it off, and it will wait until it needs another cue. So let's turn it on. Oops, try it again. So you'll see that bang is turning it off for us once it's finished. Great, so I'm happy with that for now. One other thing I'm going to do here is I'm going to select all of this. I'm going to duplicate it across, and I'm going to reverse the order of these cables here because I want two sounds. I want a sound to go up. This is for when the Bitcoin price rises, but I also want it to go down in the reverse order for when the price lowers. So we can simply do that by deleting these patch cords here of the cycle and reversing them. So the first note will be here. The second note will be here. So the first note is now the highest note. The second note is the second highest note. And we go back like this. So we're kind of doing it in reverse order. And what we need to do is we need to take this device that we have here over and make it apply to this guy here, because this guy is now the last in the sequence. So we'll drag that down here. Let me just rearrange these patch cords to make it a bit more clean. So once again, because the cycle is now reversing, it's playing this one first and then this one last, we need this one to be the thing that tells the toggle to turn off. So again, we need the value or the integer to go to this make note, and the I, oops, excuse me, wrong way. So this is the integer. Let's just drag it straight into there, and the bang now comes out and turns it off. So let's have a listen to this one. And I need to connect the 86, of course. I missed that cable there, that connection. So we have it, the price going up, and we have the price going down. Awesome. So now what we need to figure out is, well, how do we know when the price is going up and the price is going down? And what happens at, you know, what's going to happen when the price is really low compared to just a little bit low, or really high compared to just a little bit high? Well, what we can do, like we did before with the pulse width thing, is we can give this metro a certain parameter. So we can give it a certain rate, if you like. So I'm going to go in and create a new live dial here. And again, we'll go into the inspector. How fast do we want this to go? Let's make it, we have to change the range here. Let's make it 50 milliseconds is the fastest it can go, and 1000 again. Let's stick to what we did before. So that is the maximum and minimum, and then let's just call this up rate, like so. So now this live dial goes from 50 to 1000. We connect it to the metro, which of course determines how fast the sequence will play, and let's have it at 50, make it real fast. That's good. Now let's bring it to 1000. Great, so now we have a slidable knob that will change depending on what the current rate of this Bitcoin does. And we're going to create a velocity machine in a minute, which will convert the velocity into a rate for us. But just for now, I'm going to copy over the rate here, over here, because we want this one to also apply to when it goes down. And we need to go into our inspector, and we need to we'll just change the name. So call this down. I'm just going to call it down. I'll call it D rate. Sounds good. So now this one. Great, now what we need to do is we need to have this actually trigger when something happens. So for a start, let's add, I'm going to add a message box here under the note in, and I'm going to drag the velocity down just to see what we get. So let's close down this inspector, close down this, we don't need you, and let's just play a note live. So I'm sending 100 velocity here. let's add a MIDI clip in here and play a note. Oh, what I need to do, sorry, one thing I need to do is I need to get rid of this MIDI in to MIDI out thing now, because this was allowing us to play any note into the MIDI effect and then out of the MIDI effect. We don't want that because this note in is going to take over all the work, so I can get rid of that now. So we're not going to be able to hear anything for now, but let's add a C here. I'm just going to play C, and if I hit play, you'll see it's playing at 100 velocity. Okay, cool. But if I change the velocity here to say 15 and hit play, wait for it, 15. So it's sending 15. So we know that this will take whatever the velocity is sent to here and it will give us a number. Now velocity again goes from 0 up to 127. So what we need to do is we need to split the velocity into two groups. Excuse me. So from 0 to 63. Remember 0 is counted as a unit. So from 0 to 63 we want the velocity to get sent to the down, because that's the lower half of the velocity range. 0 to 63 means the price is going down. We want it to trigger this area over here, which makes the sequence go down. Whereas if it's 64 to 127, we want it to go up into this area here. And we can do that by using a new object here, and it's called an if statement. Now, if you're into programming and coding and stuff like that, you're probably familiar with if statements. It basically says, right, I'm taking something in, and then if that thing matches or has some relation to something else, do something. If it doesn't have a relation, do something else. So we do that by saying if, and we need to say after if, we need to say, right, what is the information we're feeding in here? So I'm going to say dollars, which means I'm giving it like a variable. It means it's going to receive something. Dollar symbol means it's going to receive something. I'm going to push I because it's going to receive an integer, which is a whole number. So we're not using float numbers because there's no decimals in this 0 to 127. They're all whole numbers. So dollars integer 1, which means it just gives it a label. So that means if $I1 is if it is less than, more than, if $I1, excuse me, I need a less than, $I1 is less than 64, then again $I1. So that means if $I1, which is the input I'm giving it, if the number I'm giving it is less than 64, then just output the number and it will output the number through the left outlet. However, else, that means if it's not less than 64, if it's 64 or more, then I want it to go out the second outlet, and I push the $I1 again. So that means a number's going to come in. If it's less than 64, go out the left. If it's more than 64, go out the right. So that should work like that. Let's just add a few numbers in here. Let's just say 20. This is just for testing purposes. And we'll go 70. And we'll put a message here and a message here. So I'm going to feed these in here. Remember, they won't be active until I actually click them. So 20. Okay, 20 is less than 64, so 20 comes out this side. 70, on the other hand, is more than 64, so it comes out here on the right side, which is the out 2. So this is good. That means that now when a velocity comes through from this note in, if it's 63 or below, it will come out this side, and we can send it, well, it needs to go over here. And if it's 64 or above, we can send it over here. Awesome. Now I'm going to get rid of these here. I'm going to be using something here called a live number box. This just gives us a good a good box that is only uses numbers, so it kind of just makes things a little bit easier to see and recognize. And by default, these go from 0 to 127, which is perfect because that's what we're working with. So let's drag that down here, and we're going to drag this down over here as well. So I want so if it's less than 64, I want this value to be sent to this uprate. So that means I need to scale this. I need to say, well, okay, sorry, first off, we need to say if it's 0, disregard it, because we don't want to use 0 here, because 0 means a note off. So we're going to introduce another new object here called select or cell. And what cell does is you give it an argument. So I'm going to say cell 0, and that means when a number gets fed in here, which is coming out here, if it is 0, send a bang out this input here. So if there's a 0 fed into this object here, it's going to send a bang out here. However, if it's not a 0, send the number out here. So this is the input if the input doesn't match 0. So that's cool. So that means that it's never going to send a 0 over here. It's only going to send 1 up to 63, because remember 0 is a note off, so we don't want that. So we don't need to connect anything to this bang here. It's just going to send that out into the middle of nowhere. We're not going to need that, but we do need this number here, and this number is going to be 1 to 63. But the problem is this knob here goes from 50 to 1000. So we've got 1 to 63 coming out here, but we've got 50 to 1000 here. They don't match up. So we need to use something here which scales that first set of numbers to the largest set of numbers. And we can do this by creating a new object called scale. Now scale, you need 4 separate arguments in order for it to work correctly. We need what the input lowest number is and the input highest number is. And of course that's going to be 1. So the lowest number it's going to receive is 1. The highest number is going to be 63. Then, oops, we need to make these floating numbers as well. No, we don't, sorry. Just disregard that. So 1 and 63. Then we need to say, well, what is the lowest number it's going to output? Well, that's going to be 50, and the highest number it's going to output is 1000. So 1 to 63 is going to be fed in here. It's going to scale it to 50 to 1000. So if we connect the right outlet of the select to the scale, and we drag the scale into the live dial, it's now going to scale it for us. And I can give you a quick example here. I'm just going to drag this dial up and copy it across, go into the inspector, and we'll make the range of this 1 to 63. So this now goes from 1 to 63, and I can drag that into the scale as well, just to show you that 1 will produce 50, and as I move up, it will give us various values between 1 and 1000 up to here. So this goes from 1 to 63, this scales from 50 to 1000. It's a really handy object for converting sets of numbers and data. So that's good. Alright, now I need to do the same for this down rate. So I'm going to just copy this across. We need both of these guys. We need the select 0 as well after this number box here. And what we need to do is we need to say this one is going to not scale from 1 to 63, but it's actually going to scale from 64 to 127. Because remember, this is picking up the higher velocities, this is picking up the lower velocities. And we'll drag that down there. And that should have worked. So if I just drag this number up here from 64, you'll notice if we send it 64, we're getting up to 1000. So that's good. That's excellent. That's what we want. However, the last thing we need to do here is we're not actually turning the sequence on. All we're doing is setting the rate. So we need to add in one little part in between the selects here and the scales to actually say, once you've scaled it, actually play the note, the sequence, which means hit this 1, which turns it on. So I'm going to do that by, again, creating a trigger. Remember, this sends multiple outputs of what we want. So we want this trigger to be a bang and an integer. So remember, an integer is a whole number, a bang is a trigger, and we want it to go from right to left. So we want it to send the integer out first, which gives us our number for the scaling, and then we want the bang to send, which will turn on the sequence. So let's put that here, connect those two there, connect it into there. Oops, excuse me, I just need a bit more space here. So the integer is going into the scale, and then the bang comes down and turns the sequence on. And we need to do the same over here. So get rid of that. Bring that across, connect the select, the integer again goes to the scale, and the bang needs to come down here to turn it on. Finally, we need to connect the velocity from the note in into the to the if statement. I'm actually going to create one more select here. So what I'm going to do is I'm going to, after the note, I'm going to have a select, so if the velocity is actually 0, it's going to reset these back to 0 as well. We just want this to reset, because if we don't have that reset thing, it's going to change, say we send it a velocity of 50, it's going to change this to 50, but then it's just going to linger on 50, and we don't want that. We want it to reset back to 0. So what I'm going to do is I'm going to create another trigger here. It's going to be a trigger. This time we're going to work with 2 integers, integer and integer. We're not going to use a bang, we're going to use 2 integers. I'm going to connect the velocity to the trigger of the integers. Okay, so the first one of the integer gets fed into the if statement to figure out whether it's a low or a high velocity. The next one is going to send to another select 0. So this is saying, right, feed the number into here as well. If the number is 0, I want you to bang a message box with 0 to both of these number boxes here. Like so. So that means when the velocity is turned off, both of these are going to be reset. Let's see if it works. I hope it does. So here we have a note. Turn off the preview. It is a C. Let's put the velocity at, keep it at 127 and go. Let's make the velocity short. Let's say have it at 79. It's faster. Let's have it at 64. Let's go below 64. Let's go 46. Excellent. And we'll do it again. Let's make it really fast. 63. It's hard to drag, sorry. Hold down the command key to make it smaller. So 61 will do. Very good. So I'm just going to put a couple of notes in here. Let's make this one. Hang on, wait, did that work? Uh-oh. Okay, what I need to do here is I think I need to flip these around because I think I've done it in the wrong order. So I'm going to send this guy over to here and this guy over to here. Okay, so that means when it is at its lowest value, it's going to be fast, it's drastic. This means the Bitcoin market has crashed and you need to do something. But if it's just a small change, oops, and I also need to change the scaling round. I've accidentally done this in reverse, but it doesn't matter, I think you still get the concept, so, whoops, wicked. What happened there is I hit something on my MIDI keyboard and it crashed Max for Live. I used my elbow and I bumped something. I think I hit about 3 or 4 notes by accident on my MIDI keyboard and it completely destroyed it. And of course we didn't save. So I'm going to say that project is complete. Fuck. But you got the idea. Hopefully you followed along and learned something with that. I can rebuild that fairly quickly. So in the next video, I'll show you the actual finished product. All I had to do was switch those two around and it would have operated exactly how I liked. Please take this as a lesson that you should save your projects all the time. When I'm making videos, I have a bit of added pressure on me and I tend to forget simple things like saving. But yeah, please do save. I'm going to put this up. I'm not going to be shameful of it. I'm not going to be embarrassed. This kind of thing happens all the time. So anyway, that was my attempt at converting the Bitcoin, a Bitcoin value into something which I think sounds like a Bitcoin. Next one, we're going to be talking with Litecoin. We'll probably lay off a bit of Max for Live. We'll give you guys a break from the Max for Live stuff because I actually went into quite a lot of Max for Live stuff today. But if you have an idea for what a cool sound for Litecoin would be, L-I-T-E-C-O-I-N, have a think about it. What could you do for Litecoin? Leave me a comment, let me know, and feel free to laugh your head off at me for crashing while I'm recording a video. Cheers guys. Tom Cosm, cosm.co.nz.